Here we go. Welcome to Walk About the Galaxy, the social astronomy podcast, where the science is universal, the opinions are personal, and the hosts are keeping their distance. We are Strange Charm and Top the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney.
Coming to you from distributed, undisclosed sites across Orange County, Florida. Be sure to stick around at the end of the episode for the things we say at the end of the episode. Our stumpers are epidemiological.
Too soon.
Going with the times. Jim, I have to comment that unlike me and Addie, you do not have a super cool digital backdrop.
Yeah, this is the result of me having a much older computer than yours.
But a baby face.
Yeah, I did shave. Not for epidemiological purposes, just random once every year or two. Shave it off.
Okay, here are your stumpers. Jim, bacteria or archaea? I'm not sure I pronounced that right.
That sounds right. I don't know. I think we rarely talk about those, but I'll go with archaea. Just they're cool, different. I was years ago when I first learned about their existence, I was shocked. I thought that all single cell organisms were reasonably similar to one another, but apparently they're not. And archaea is like the third kingdom or a different total kingdom of things that are as dissimilar from bacteria as we are from bacteria, which
is pretty dissimilar.
Yeah, which is pretty darn dissimilar. So, but they're all over the place, and they're often, I guess, found in extremophile type of situations, or they're extremophiles. I think that's pretty cool.
Yeah.
Archaea. Also, I don't think they make you sick, which sick sucks. So
that's true.
That's interesting. Yeah, I haven't heard of any sort of archaeal infections. There are bacterial infections, but not.
No, they're cool. They're peace loving.
I've heard of archaic infections.
Have you?
Huh. Archaic
infections. What would that be, like Montezuma's Revenge?
Yeah, or infections you used to get that we never do, like measles. Oh wait.
Oh right. Smallpox.
Also too soon.
Yeah. I learned about the existence of archaea embarrassingly recently, and I also embarrassingly recently learned, or maybe I did learn it in high school, but then forgot, that how different bacteria are from regular cells, like the cells in our body.
Mm-hmm.
Like you call them single-celled, but they're sort of not even really cells. And some of these popular biology books say that we have more in common genetically with an amoeba, which is a true single-cell, true cell organism, than the amoeba does with a bacteria.
Ooh.
Right.
That's weird.
That is weird.
But this is the
Social astronomy
podcast. But we're a little bit preoccupied with biology these days. So Addie, your stumper is bacteria or viruses?
I'm always a little preoccupied with biology. My options are what?
Bacteria or viruses?
I mean, that's not really very fair. I think bacteria. Well, I guess bacteria. So bacteria are sort of a little bit, I think, more straightforward to
kill,
combat, except that now we're starting to make super bacteria, right? Because we're making all these people aren't good at taking antibiotics, and then bacteria get resistant and all of that. Viruses are pretty fascinating, though.
What's yeast?
It's
like for beer. What kind of animal is that?
It's a fungus.
It's a fungus.
Yeah.
Okay.
Yeah. It's a type. Yeah, it's a type of fungus.
Okay. I was trying to connect it to beer, which is more in line with things you like.
I do like beer.
Maybe I
think actually one of my homebrew or one of my isolation projects is going to be a homebrew.
Can we make a walkabout special?
Of course.
Walkabout ale or something like that?
I made a surf stout for my CubeSat, right? So I was thinking of a pandemic porter, or perhaps a beer that's an ale that's a cure for what ails you.
Ooh.
So, I got lots of options for different styles if I want to make something. But we could make a walkabout wheat.
Okay, that sounds good. I might even like that.
Yeah.
Uh, well, today we are talking about astronomical stuff, specifically quark stars, a salty
Ah,
surprise in a comet,
oh my.
a
Right.
stretchy, we'll find out, a stretchy pulsing binary star, and for the, I've lost track of how many times, the Mars Insight Mole.
Yay.
But first, this episode of Walkabout the Galaxy is brought to you by Indoor Activities. Out of ideas for outfits to wear to the club? Tired of being on at dinner parties? Stressed at the idea of losing at game night? Annoyed by the inane chatter of another first date? Exhausted by the noisy banter at your favorite bar or restaurant? Worried about the cost of another trip to the movies, a bar, Disney World, Disneyland, Universal, the hairdresser, the spa, a restaurant, the mall, or Costco? Try indoor activities for a safe and reflective change of pace. Indoor Activities is happy to bring you inexpensive alternatives to a hectic social life, such as napping, reading, watching things on screens, eating leftovers, bickering, napping, watching things on screens, vacuuming, dusting, napping, and much, much more. So try Indoor Activities, the right choice for a healthier you. TM.
I've been wearing the same pair of pants for 2 weeks now.
Is
So
that no pants?
it's pants. They're starting to be gross.
Is it the British version of pants, which is just underwear?
Right.
Please don't pan your camera down.
I will not stay in here. Yeah, that sounds like quite the life. Like I know Addie's a little bit of an extrovert. She likes people, but a little bit, yeah, which is great. Except not now. I am an introvert, and so in theory, I'd be loving this. Except that, of course, I'm just anxious, 24/7 now about
Right.
everything.
Uh,
But anyway,
for our future listeners in happier times who are catching up on a backlog of Walkabout episodes, say in the year 2022 or something like that, we're recording this in March 2020 when everybody's a little bit preoccupied with COVID-19. Uh, and that sort of is our Earth news. Enough said, perhaps.
yeah.
Back in the 1920s,
Yeah.
uh, they also had a pandemic, and they also had a stock market failure, and they also had a bunch of other stuff. So, yay, go 20s.
Right.
Yay.
Well,
Anyway,
let's look up to brighter things. So space news.
space
Uh,
news.
there was a launch of Starlink, another giant
Another
program.
one.
Yeah, so there's 360 of these things up in orbit now.
Yeah. And this was one of the few SpaceX launches that there was an issue with one of the engines, and actually the booster didn't land.
Oh, is that why? I know that it had failed to land on the drone ship out there. This is actually the first time they had flown a booster for the 5th time.
Yeah, that's true. But they did end up recovering both halves of the fairing.
Oh, really? Both of
Hmm.
so they have these 3 ships out there to catch various parts of their rockets.
Yeah.
There's the landing, which they've been remarkably good at, but they've actually the last couple have missed, I think. And uh, and then they have these other ships with these like giant nets.
Yeah.
They're
And
hilarious.
it sounded like they didn't actually catch them in the nets this time, but they recovered them. So I think maybe they got in the
Oh,
water and then they scooped them up.
okay. Yeah, I
They went
think that,
fishing.
yeah. So are there people on those boats with the nets to get the fairing halves
There are people on the net boats. There aren't people on a
on
drone
the
ship.
rocket boat? Yeah. So yeah, the fairing is the sort of aerodynamic shell that protects the satellite as it's blasting out through the atmosphere, and it so it's sort of clamshell splits in two, and then they have parachutes on them or parafoils so that they sort of do a controlled glide
Yeah.
down and try to
Yeah.
hit land in these nets on these ships. But
Yeah.
if they go in the water, I guess they float for long enough for them to fish them out. That's cool. But there's other SpaceX news.
What were you going to
That
ask,
launch,
Jim?
by the way, that launch nearly cost me my eyesight because that was a couple days ago, right? And it was a morning launch,
Oh, no.
and I went outside, coming directly from bed where my eyes were closed, and then stared directly at the sun for 5 minutes trying to see the launch. I never did see the actual rocket. I just saw the sun for 8 consecutive hours after that. So
Oh,
Oh,
no,
no.
Jim. You're not supposed to look at the sun.
I was looking directly at the sun. I was going full Galileo or Newton or whatever that was. It didn't work.
Didn't work.
there are ways to block out the sun.
What?
SpaceX has said that it's going to start working on different ways to create better camouflage, if you will, for the Starlink satellites. They're saying that they're going to maybe do a um, a star shade kind of thing or something, and some other paints and stuff like that.
I heard them talking about like there are certain orientations sometimes where there can be particularly bad glints or reflections, and they're trying to work out ways to maybe protect those. So maybe that was related to the star.
Maybe they need to head down to Bass Pro Shops. They got all kind of camo down there.
Huh.
But there's more SpaceX news with Crew Dragon.
Crew Dragon is supposed to launch in May.
And that's exciting.
It is.
So are the timelines for all this stuff likely to be affected by all this business?
So yes and no. So Crew Dragon is the SpaceX Dragon capsule with two astronauts that's going to go up to ISS. And so they did the uncrewed version already, and now they're going to have the crew version hopefully in May with 2 people on it. And there's interesting questions about whether, so it was planned on just being a quick up and back, but now there's questions about maybe if they're going to actually stay a while up on ISS, because we have reduced capacity up there right now because they're not launching as many Soyuzes.
And there's the delay. The delay with the Boeing also is affecting the ability to get people up there, because I think we've basically used up all our tickets on the Russian rockets, or maybe we have more ticket.
Yeah, so they had scheduled a certain number of Soyuz launches, and then they had planned on reducing them at this point because we were supposed to have SpaceX and Boeing flying, but since we don't, they still have a reduced crew load up there right now. So,
right.
But what was your question, Jim? I forgot already.
Oh, I was wondering how all this COVID stuff is going to affect. I mean, do they need large groups of people together to get these things moving on, or can everybody just work from home and then they can launch this thing?
So certain things at NASA centers are still happening. Folks are still working on site, I think, and like they actually quarantine astronauts for a couple of months before they're supposed to go up anyway. So like the next Soyuz that's supposed to launch, like those folks were actually already sort of in a quarantine before all the COVID stuff started happening. So it's just like even more quarantined now. And I think they're going to try to keep it on schedule. It might slip a little bit though at this point.
The Mars Insight mole
is in the ground ish.
It's moved another inch or something.
Yeah, they were like, what if we just push on it? And that seems to be working.
This we've talked about before. It hit something and then it backed out, and then the hole was too big because it sort of is like a jackhammer, and it needs the friction of the hole that it's in to sort of push against, and it lost that because the hole got sort of too big. So then they tried using the scoop as a side pusher. Now they're like putting the scoop down on the top of the thing to apply some pressure, and they've hammered it like 20 times, which is supposed to make it move a couple inches, and they think it moved maybe a half an inch or an inch or something. Yeah. That's the last I heard on it.
There's a nice little gif of it going in a little bit.
Okay. So it's still far short of its target goal of like 10 to 15 feet.
Yeah. Just a little short.
We're still in the a few inches realm, but there's some cautious optimism that maybe this new technique will get it past whatever stopped it the first time around. So let me drop on you what our trivia is going to be.
Okay.
And then we'll talk about these funky stars and the comet news.
Great.
You may probably know this, but maybe not all of our listeners do.
Okay. No pressure.
So
I don't know it.
Huh?
I don't know it. Go ahead.
Okay. I bet you do, Jim. But we'll see.
We'll see.
This is about things called platonic solids, or
Okay.
more prosaically, they're referred to as finite convex regular polyhedra. And what that means
I
is,
thought it was going to be like all women to me.
What?
Platonic solids.
Uh,
Because they wouldn't date me. Because anyway, go ahead. Sorry.
all that's why, Jim. That's why they won't date you.
Yeah.
oh, the classic physics joke.
Yeah.
Anyway, go ahead. Platonic solids.
Platonic solids, they are thingies that are made up of a bunch of sides, and all the sides have to be the same. And they all have to connect along the same number of edges, and the same number of sides have to meet at each pointy place, which we'll call a vertex. So the simplest one of these to visualize would be a cube, which
Okay.
has 6 identical faces that happen to be squares. Those faces meet at 8 corners or vertices, and each of those vertices is the meeting point of 3 faces and 3 edges, and there are a total of 12 edges. So the question is, it's a 2-part question.
What?
What? I'm shocked.
The question is, how many of these things that can be formed by identical sides or faces, all flushly meeting at with the same number meeting at each vertex and each edge, like a cube is with squares. How many of those things exist in 3-dimensional space, part A, and what is their connection to the history of astronomy, part B? So that is our trivia for today. It's geometrical. And I think we can use that to launch into the comet news, because
Okay.
the comet was Comet 67P. They initially we said, oh, it looks like a rubber duck, and then we have these sophisticated shape models of it. They're assembled by polyhedra. So that's the segue from the trivia. But our news
Ah,
about the
great.
comet doesn't have anything to do with its shape.
No. Yeah, this is the Comet 67P that we sent the Rosetta mission to. And the Rosetta, so this Rosetta spacecraft orbited 67P for a while. Still results coming back from that mission, even though the mission is no longer like actively sending back results, we're still analyzing it. And there was this question about some nitrogen content, how much nitrogen there was in the comet, and it seems to be missing. Like we haven't been able to detect as much as we thought should be there. And this basically they're looking at the ratio of nitrogen to carbon, and it seems like there's not enough nitrogen. But there's a new study which they have looked at some of the outgassing features from the comet 67P, and they find that ammonium salts, so ammonium salts are usually like a nitrogen and some hydrogens, will could be locked up into some of the features that we see, and it creates absorption bands that we actually see in spectra. And so it's likely that some of the nitrogen is locked up there. So it's locked up in salts. So that's why it's a salty comet.
So this was done by some laboratory measurements, I think in France, right, where they basically said, sort of the classic good experimental scientific technique is, let's try to build something looks in the in the lab, and then observe it the way we observe the comet, and we'll tinker with the thing in the lab until we get something that looks like what we saw with the comet.
Yeah, and I think they weren't even intending to like solve this mystery, but they ended up figuring it out based on these lab measurements that they had gotten.
So yeah, there's a lot of the study of comets is connected back to the delivery of some of the sort of materials of our biosphere on Earth to Earth. Earth has got a fair amount of water and other nice things for life, but it's kind of a little bit close to the sun to have a lot of that stuff. Like the watery part of the solar system is really further out where it was colder. So there's a lot of discussion in planetary science, just like, where did the water come from? And part of how they study those types of things with what are called volatiles, things that are gaseous at low temperatures, are by looking at the isotope ratios of them, sort of what version of things they are, and comparing what we see in asteroids and comets to each other and to what we see like in ocean water on
Hmm.
the Earth. And apparently the carbon-nitrogen ratio has been a mystery um, in comets, and where's the nitrogen hiding? So they think it's hiding in these ammonium salts.
Yeah, and we compare that to the abundances we see on the sun. So most things we do in astronomy and solar system astronomy, we compare to solar abundance, and we expect that since it all formed from the same material, you'd expect similar abundances. Um, and it turns out maybe it's locked away in some of these salts.
So you mentioned that um, this particular discovery is made by sort of matching a particular spectral absorption feature.
Hmm.
And the paper notes that there are some asteroids, both in the main belt and some of Jupiter's Trojan asteroids, that also have a similar sort of absorption feature out at
Hmm.
3.2 microns. And I'm going to do a stretchy segue here because in the ultraviolet, in a completely different part of the spectrum,
Are you
comet,
going to tie it to Cassini?
yeah,
Yes.
comet 67P looks like Saturn's rings in the ultraviolet. So
Ooh.
there's something dark in Saturn's rings that's called the ultraviolet absorber, something that makes it very, very dark at very short wavelengths of light. And we're not sure what that stuff is,
Mysterious.
but it does appear to be similarly spectrally to whatever it is that makes Comet 67P dark in the ultraviolet as well.
Huh, that's interesting. I mean, it makes sense, right? They're sort of outer solar system objects. They have a lot of ice and then things that make them dark.
Right.
So do you think that, are there some hypotheses that ammonia salts could be in Saturn's rings?
Oh, no, I don't know.
Oh,
I don't
well,
know.
now there can
I
be.
should, I should know, but I don't know.
There you go. Got yourself a paper, Eddie.
Yes. I have
But
nothing else to do. I'll just type that up real quick.
There you
right.
go.
There definitely are a lot of data about what Saturn's rings look like in the infrared, and it's crazy complicated. And it's mostly water with
And
little
and
tiny bits of other stuff.
yeah.
Yeah. Okay, now we're jumping out to the outer solar system, not the outer solar system, beyond the solar system. What am I talking about? Stars.
Stars.
We were just in the outer solar system.
We were just in the outer solar system.
Yeah.
So we have a couple of star newsy things to talk about. One isn't really super news, but it popped up in my news feed and it was too cool to pass by, which is about quark stars.
Quark.
That's us.
That's us.
We get our first big movie role. That's going to be us.
The quark stars.
Quark stars starring astroquark stars.
That's right.
That's right. That's right.
So
yeah,
Jim, what is a quark star?
Addie.
Yeah. A quark star isn't a thing that we know actually exists. It's one of those things that theoretical physicists like to champion. So it may or may not be real. The idea is, we when stars die, various things are left over. Like when the sun dies, we'll have a white dwarf as the core remaining. When larger mass stars die, they blow up, and what's left is often a neutron star, or if the mass is too large, a black hole. But there may be a kind of fuzzy zone between something that's a neutron star and a black hole that is a quark star. So that is, some massive stars could collapse to become these quark stars, which basically is that the temperatures and pressures are high enough that neutrons are made up of quarks, right? And they're made up of a bunch of up quarks and down quarks, not
Yeah.
us.
I was going to say, aren't all stars technically quark stars?
Well, in some sense, yes, but quark star, it's really hard to get a quark by itself, right? It's always locked up in these little like triplets, like two ups and a down or two downs and an up to make a proton or a neutron.
Or a
Or a
strange
strange charm and top.
There you go. But it's so hard to do like we're doing right now and actually separate them. Usually we're all together, we're hanging out. Now we're separate. Getting a quark by itself is next to impossible. You have to have
social distancing.
Yeah, you'd have to have a serious virus.
Oh no.
Or just ridiculously high temperatures and pressures. And it's conceivable that in some narrow range of stellar masses that you could have a soup of quarks in the center of your collapsed thing rather than a big bunch of neutrons by themselves. And that would be cool because it would be smaller. So this is something that would be under even greater pressure than a neutron star, so it collapses even further. I mean, neutron stars are pretty small. They're like the size of a city or something.
Tiny.
This would be half or a tenth or something that radius, but still not fully collapsed into a black hole. If such a thing existed, it would be awesome, but we don't know.
Well, if you break the, so you're talking, so gluons is the stuff that holds quarks together, like inside a neutron or a proton. Is that right?
That's true.
So somehow you're overcoming whatever the strength of the gluon is to hold those things together, and you make this sort of sea of free quarks in this hypothesized quark star,
Right.
and that's denser than a neutron star. And you mentioned that it required high temperatures and pressures. As the thing cools, does that allow the quarks to recombine into neutrons?
Conceivably, right? I mean, it's conceivable that maybe these things only would last a while until they cooled down enough to turn into it. The trouble is that we don't have a good understanding of what in physics we'd call the equation of state of this kind of matter. We don't even have a good understanding of the equation of state for neutrons in a neutron star, so it's even less understanding of what would happen in that. So I could see that as conceivable, but I have no real idea what would happen.
But it's great fun to speculate because, like, the equation of state is the thing that sort of describes when water becomes ice or steam and where that transition occurs and how it compresses depending on what the temperature and density and all those things are. So it's the relationship between the volume and the phase of that stuff. And so this sort of sounds like different phases of quirky matter. Like,
Yeah, and there's all kind of crazy fun things that I mean, like it turns out that if all you do is kind of melt the neutrons into up and down quarks, you're going to get in trouble because that stuff turns out not to be stable, at least according to the calculations. But if you sprinkle in some strange quarks, then you can make a more stable situation. So the
I
thought is
don't think that's based on fact.
true. Strange quarks make things
I'm
smaller.
I'm very stabilizing.
Okay.
So maybe, and strange quarks can be made with various interactions of the available quarks that they have. So could be that there is some mixtures of up, down, and strange quarks that are stable and that exist in the hearts of these things. And I think, what I saw recently is that we do have one candidate star that we had first classified as a neutron star, but when they made some measurements of its radius, found that its radius was too small to be a neutron star. I mean, neutron stars have kind of a minimum size that they can stably be.
Yeah.
This is considerably below that. Now, I think that the majority opinion is that most likely they're just incorrect in their measurements of the radius, that there's enough uncertainty in that measurement that it's probably just not that. But if they're right about their measurements of the radius, then that is probably a quark star. So.
Yeah, because this comes back to one of the things we talk about, right? Is like, okay, well, you have to figure out how far away it is to figure out what its radius is, and there's just a lot of uncertainty in how far away it is, and that's how wide it is.
In a sense, yeah, I think this radius measurement is not that kind of radius measurement. That is, the radius is not measured by looking at how big it appears in the sky and how far away it is. It's made based on how quickly it changes. I mean, small things can change very quickly and big things take longer to change because it takes a while for the change to propagate through the thing. And so you can kind of get an idea of the radius of a thing by how quickly like its luminosity changes. And that's the kind of way that we did it for this, or that I say we did it, I ain't have nothing to do with it, but how they did it. So, but again, it's like you said, there's a lot of uncertainties in a lot of our measurements. And so when you're making measurements like this, you're probably combining 2 or 3 different things or 4 different things that all have big uncertainties. And so we could be very wrong about the radius.
Right.
But we're working on it.
That's cool. My last question about this thing is there a way that we can use a quark star as a gimmick for like a science fiction movie or TV show or best-selling novel?
Of course.
Hell yeah. There must be.
Yeah.
Okay.
Let's work on it.
Another project for the Astroquarks to work on.
Go. It's going to be our first big screenplay. All right.
All right. Before we do our last science topics about another kind of star, a new sort of unusual star discovery, let me get your answers to part A of our trivia. for this episode. So as a reminder, the question is just how many things like a cube, how many different perfect or platonic solids can exist in three-dimensional or do exist in three-dimensional space. And a perfect solid is one where every face is identical. So a cube has got 6 identical squares, and they all fit together perfectly with no gaps or anything between them. And so that's one of them. So there's at least one. How many shapes like that exist in three-dimensional space? That's part A. Part B we'll come back to at the end of the show is what's their connection to the history of astronomy. I'm going to give you multiple choice for how many of these things exist in three-dimensional space. Your choices are A, 5, B, 9, C, 12, D, 24, or E, 87.
I really do feel like I should know the answer to this question. I feel like I've come across that at some point in my life, and I don't.
I definitely have talked about this before, but I don't know if I know.
Yeah, I know the answer to part B, but I don't know the answer to part A.
Really?
I'll make a guess after Addie makes a guess.
12.
Okay. Addie's guessing 12. C.
I kind of like that. I'm gonna go with 9.
I don't know why I sort of assumed you guys would know this, because it's sort of an arcane bit of knowledge, but
Reveal, you might say?
both of you are gamers,
Are there
as
are there
these
5?
shapes are related, our dice are made from these shapes.
Yeah, there's 5.
There are 5. There
Yeah.
are only 5 shapes that exist in three-dimensional
I was
space.
gonna guess that because of the answer to part B, which is
Right. Well, we'll come back to that.
We'll come back to that later.
All right.
Save it.
Yes.
Yeah.
We're going to tease for a few more minutes. This last stellar story has to do.
So wait, should we say what the 5 are?
Oh, sure. Go ahead.
They're cube, tetrahedron.
Yes, that's 4 triangles, 4 identical equilateral triangles.
Then there's like what's the one? Is
There's
it a
dodeca-
octahedron? Is it an octa?
octahedron, which is like 2 tetrahedrons stuck together. So it's 8 triangles.
There's
Then
a dodecahedron.
Right. That's 12 pentagons.
Okay. And then what's the last one?
The last one is, Jim?
there's a 12-sided die.
That's the one we just did.
That's the dodecahedron.
Oh, then there's a 20-sided die also, which
Yeah.
is,
Well, what's that called?
I don't know.
I should know
It's called an icosahedron. Icosahedron.
Icosahedron.
I thought the icosahedron might have been the 8-sided. What's the 8 one called?
Octahedron?
Octahedron. You said that right. Sorry. Okay.
It's okay. I was like, is this a trick question?
No, yeah, you said it. Okay. So in any event, there's one other sort of unusual star in the news, which is a stretchy, pulsy binary star.
I thought you were going to say something about like Sean Penn or somebody. I don't know.
So most stars we've talked about before come in binary systems where they're orbiting each other, and frequently they're orbiting each other super closely. And when they're close to each other, they stretch each other out. Their gravitational pulls stretch each other out. And then there are also, sort of independently of that fact, stars that pulsate naturally and periodically. And some of these pulsating stars have these interesting relationships between how frequently they pulsate and what their brightness is. And we use that to help figure out how far things away are. They're like flashing lights, and the faster they flash, the brighter they are. And so then we can look at them and say, oh, that's a, this kind of flashing light, so it must be this bright, and it looks really dim to me, so it must be very far away. So these pulsating stars are super handy for figuring out how big the universe is. And there's a kind of pulsating star, which I just love the name of it, so I wanted to say the name of it, which is a Delta Scuti pulsator.
Ooh.
And
named after Delta Scuti?
Yeah.
A well-known actress?
Delta Scuti being one of the bright stars in the lesser-known constellation Scutum, is
My
a
next
pretty.
cat is going to be named Scootum.
Yeah.
I think it's sort of an unfortunate name for a constellation or a cat, to be perfectly honest. But
I made an awesome joke about that in one of our astronomy fun facts of the week, which are really like astronomy fun facts of the quarter year or something like that. But
they're
They
of the
happen
week.
in a week.
They're of the week, just
there,
not
yeah,
every.
they're that week. They just don't happen every week.
Right.
But there was some cool star like YU Scooty, and I made a great cat joke way back when. Anyway, continue.
Well, this particular star has got a less poetic name, HD 74423, but it is of type of Delta Scuti pulsator, which is also called, I think, a small Cepheid or something like that. Anyway, it's a pulsing star whose brightness fluctuates in a relationship to its brightness, to its overall brightness, which is useful for figuring out, like in this case, how far away the Magellanic Clouds are and sort of those kinds of scales, not on grand cosmological scales. But it's a binary star, and the star's orbital period is about 1.5 days. And what they found is that these stars, even though they're on a circular orbit, the pulsation, instead of being a sort of spherical pulsation, has blobbed onto the teardrop axis that is pointing towards the binary star because it's being stretched that way. So only that blobby part is pulsating. So all the pulsy part is in the blobby part. And that's where so it's an alignment of the pulsation axis with the tidal axis, which has never been observed before.
Hmm.
That seems like
Yes.
a really difficult measurement to make. But didn't they make that with one of the planet hunting things?
They did with TESS, the
With
Transiting
TESS.
Exoplanet Survey Satellite, and it wasn't caught by the automatic planet detection things.
Yeah. So this is another one of those cases where a lot of this data is available for sort of citizen scientists, and so a couple of citizen scientists sort of flagged it as like, this is an interesting case. You should go back and look at it, which is pretty cool.
And they did, and they were like, "Oh wow, this is this thing that we hypothesized would exist, but had never seen before." So that's
Yeah.
really cool. Makes me want
Yeah,
to.
it's cool that you're looking for something totally different as a planet hunting thing, but you're going to find all kinds of other awesome things in that data. I mean, I guess the software worked well to not flag it as a planet candidate because it's not, but then it's cool that we have other people looking at that stuff to find all the other cool things that you might find.
Yeah.
Yeah. And here's a plug, if you're sitting at home and you have a lot of spare time on your hands, that a lot of these citizen science on like Zooniverse and a couple of other places, you can go and do those while you're hanging out and learn, maybe discover your own teardrop star.
Yeah, I want to do it.
Yeah. There's also there's a citizen science one for COVID-19. It's called like folding. What's it called?
There's a protein folding at home thing.
Yeah, folding at home. And so that's a thing where you can try to run some software in the background basically and see if you can help solve some of the problems we have with some of these viruses and other things.
There are a lot of these really cool citizen science at home projects now. We all have so much incredible computational power.
Yeah.
The computers that we've got now are so powerful, and we're using them to like play songs and browse the web, but they're really capable of doing a lot of more advanced work. So
Yeah, the folding at home reminds me of SETI at home, which was one of the super early ones. It just was like when you're not using your computer, it would run stuff in the background way back in the day.
Yeah, that would have been awesome. That was awesome because you could find like you could be the one on your computer where the first alien signal was ever found.
Yeah.
Unfortunately, it didn't happen yet. But
Not yet.
Not yet, but we'll post some additional links to that on our various sites. So let's come back then, and Jim will let you answer the part B of the trivia, which was, what is the connection of these platonic or perfect solid shapes to the history of astronomy?
Yeah, and this is the reason I should have known it was 5, because I remember this had to do with Kepler.
The person, not the satellite.
Correct, the great Johann Kepler, and he had these ideas about the solar system, and he desperately wanted to test these ideas, which meant he needed data, which is why he went to Tycho Brahe to get all his data and so forth. But anyway, one of his ideas was that each of the planets was associated with one of the platonic solids, and of course, at that time, they knew of only 5 planets, right? There was what? Mercury,
Mercury,
Venus,
Venus, Mars, Jupiter, and Saturn.
right? Other than planets other than the Earth, of course. And so
Because it wasn't known at that time that the Earth was a planet.
right, right. And of course, this was before the discovery of Uranus or Neptune. Those things are a little bit too dim to be seen by the naked eye, or at least recognized as planets in Uranus's case. So he tried to like make these like nested solids, right? Like put one inside of the other, inside of the other, inside of the other, and have that correspond to where their orbits were, or something. Some kind of model like this is what he was trying to do. Maybe you know more about that than I do, but so that's why I should have known it was 5.
Yeah, the idea, and I think he may have actually been using the Copernican model with the Earth as a planet where the solids represented the space in between the 6 planets, the
Mm,
5 interplanetary
Oh,
spaces. So in between the sphere that Mercury is on and the sphere that Venus is on, you put a cube. And then in
right,
between the sphere that Venus is on and the Earth is on, you put a tetrahedron. And he thought that it was just too much of a coincidence, these numbers, like 5 perfect solids. Why aren't there 397 or, whatever? There's
right,
just this number that exactly matched up with what at that time was believed basically to be the whole universe, right?
right,
The universe was just like the sun, the moon, the stars were just like one shell out there, and these planets. So he really wanted, and I have I Kepler was a weird dude, but but I admire him for as much as he so desperately wanted that to be right, it didn't work, and so he just like, I guess it isn't right, and he didn't
yeah,
like, fudge things or change things around. Just like crap, and he up ended up discovering what the actual shapes of all those things are somewhat later.
yep, yep.
Cool. While it may have felt like an extended period of sheltering in place, it was just another episode of Walkabout the Galaxy. If you liked this episode of Walkabout the Galaxy, write us a review in the DNA of a perfectly harmless virus. Be sure to like us on Facebook to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see this episode with its auto-switching video capture. Catch up on old episodes wherever you get your podcasts. We're now on SoundCloud, new
cool.
destination. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Our production assistant and video guru is Diego Rodriguez. Thanks to our listeners everywhere battling COVID-19. Keep calm and walk about on. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the AstroQuark signing off until the next episode of Walkabout the Galaxy.
Wash your hands.